Hello everybody! We are moving forward into our rational unit. Today we're going to look at multiplying rationals. Remember, rationals, just another word for a fraction. And we're going to multiply them, which is one of the easier things you do with them. So first of all, let's talk how do we multiply normal fractions, fractions that don't look strange. So we have two random fractions, and normally we can multiply the top, 8 times 7, and the bottom, 3 times 8. And that's how you normally multiply fractions. So 8 times 7 is 56, and 3 times 8 becomes 24. Ta-da! But for a brief second, let's take that backwards, and let's see what it looks like before you get 56 and 24. For just a brief moment, before that answer shows up, you have the two groups, 8 times 7, and then you also have underneath it the groups 3 times 8, because they're all smushing into a single fraction, smushing being a very official math word. And if you remember from yesterday, top and bottom can cancel. They can divide into a 1 before you even get started. So look back at the original answer of 56 over 24. That can be reduced by 8 into 7 over 3. You can take an 8 out of both. Now, if you destroy the 8 before you even need it, before you get to the answer, you can jump straight to the reduced form. Okay, so those 8s, top 8 numerator and denominator bottom 8, they can cancel ahead of time, just like top and bottom can cancel in a single fraction. So you can cancel with the bottom of another fraction as long as you are multiplying. Okay, so keep in mind though, you do have to be multiplying. So we're going to review how we cancel things, because the rules for canceling are the same within a single fraction as they are with two multiplying fractions. So you can cancel lone numbers. They can also reduce. You can cancel lone variables. You can also reduce them with exponents. And you can cancel polynomials. But one thing you cannot do with polynomials is you cannot cancel parts of them. You either have to cancel the entire polynomial, and we'll set them apart with parentheses so we know what the entire thing looks like, but you cannot cancel part of a polynomial. It's either all or nothing on the polynomials. All right, so let's try a few. So we have two multiplying fractions. The dot in the middle means these guys are multiplying. Okay. Let's look for some lone numbers. There's a 10 times a 7, there's a 2, there's a 5. Remember, you can cancel any of the tops with any of the bottoms, or reduce them. And the 10 and that 2, they can reduce by a 2. Remember, reducing is we're dividing. So divide them both by a 2 and you get 5 over 1. Well, this leads to something else, because look, there's another 5 also in the bottom. And 7 and 1 aren't going to cancel, but that 5 on top and the 5 on the bottom, they will cancel. All right, we have just canceled some numbers or reduced them to a 1. Now, we do have some lone variables as well. We have a numerator that will cancel with a denominator. Even though they're not in the same fraction, they're smooshing into the same fraction. And let's just write what's left. So the 10 is completely gone thanks to the 2 and 5, so 7 is the only thing left on top. The x's are totally gone. The only thing on the bottom is that 1, and 7 divided by 1 is just 7. So we took a weird-looking fraction and came up with the number 7. Pretty nice. All right, we're going to come over here. We're going to be looking for the same thing. Okay, we're looking for lone numbers, lone variables. Polynomials, the way you can tell if you've got a polynomial is if you have a plus sign or a subtraction sign joining things. Okay, they join the terms. No plus signs, no minus signs in this problem, so no polynomials. But we do have some lone numbers. The 9s can cancel. Looking around, we've got x's all over the place. So we have an x on the bottom, 2 and 1. We have actually 3 x's on the top. I like to cancel exact looking things because then I don't have to think too hard about anything. So the x squared is still there because we just took out the only thing that could cancel it. 10 on top, 4 on the bottom. They're not identical. They don't cancel, but they can reduce. You can pull a 2 out of each one. Remember, you're dividing that 2 out of each one. That takes us down to a top 5 and a bottom 2. And I don't see anything else in here. So anything that's left, you've got 5 and x squared left on top. And then on the bottom, pretty much everything disappeared except for that 2 that was reduced out of the 4. And nothing else can cancel or reduce. So that's it. That's your end answer. So it's a lot like canceling in a single fraction. It's just that there's now more to look at. All right, we're going to start getting into things that may or may not have polynomials involved in them. And we're going to find out that actually the same thing. So look for plus signs and minus signs. Okay? And most of them in this problem are actually already protected by parentheses, but there's this guy down here. He's got a plus sign, and he is not protected by parentheses, but he is a polynomial. So I'm going to fill in the parentheses just so we can see that he's a polynomial like that guy up there. And hey, look, they're exactly the same. They can cancel. So we're canceling all of it. We're not canceling parts of it. We're canceling all of it or none of it. We've also got some lone numbers running around. They're exactly the same. The 10s can cancel. We could have looked at 8 over 10 and reduced it, but we would have gotten the same thing eventually. It's just easier to cancel things that are identical because then it's totally gone. Then you don't have to worry about it. Okay. So we've got an 8x on top. He cannot work with the 2 on the bottom because the 2 is part of a polynomial. We have a 5x and a negative 2 on top. On the bottom, we have a negative 5x and a positive 2, and it's not in standard form. I'm going to rewrite that in standard form just so we get a better idea of what it looks like when we're comparing it to the last polynomial. So now it's in standard form with the x in front and the constant in the back. And look, they're exactly opposite signs, both parts of the polynomial. The front is negative and positive for the other one, and then the back is positive, negative. They're exact opposites. Whenever you have that happen, there's this trick you can do. You can factor out a negative 1. And so I'm just doing this to the denominator. I'm going to factor out the negative 1. It's a sign changer when you do this. Okay, and you should be able to distribute it through and get back to the original. So we've taken that denominator polynomial and changed it into a negative 1 outside of another match. So they can now cancel. So watch for things where the sign is basically reversed. Okay, where everybody's the same except for everyone has a reversed sign. Everyone, including front, back, middle, everything. All right, so let's look at what is left over. Everything vanished from the top except for that 8x in the very front. In the bottom, everything vanished except for that negative 1 that we pulled out to force a match. So there is a negative 1 on the bottom. And since we've got lone numbers, we can actually divide those. 8 divided by a negative 1 ends up being negative 8, and then there's your x. And that is the answer. So we took a fairly long problem with a lot of different working parts and a lot of things going on and made it very, very simple. So this can be a big time saver. If you can find things that cancel out, you can make problems much simpler. All right, so the last of this group with some pretty simple polynomials, Okay, we've got more polynomials that don't have their parentheses. I'm going to give them their parentheses because it prevents me from canceling things I shouldn't. Okay, so make sure you've got your polynomials safely tucked away in parentheses. You either cancel the entire parenthesis or none of it. Well, we've got some x minus 7s, and they look like they can cancel each other. We also have an x plus 4, but then we've got an x plus 4 with an exponent. And you can actually treat these. There's one parenthesis on top and two of them on the bottom. Well, it'll cancel one of them. If you need to, you can write out what the two parentheses look like from the bottom. And that top one only cancels one of those guys. So you can choose which one you don't like and cross that one off, I guess. Maybe you don't like the back one. Maybe you don't like the front one. Okay. You can also do it with exponents the way you would with just lone variables. But you can also make it appear if you want a visual representation of what's going on. Okay, and we've got on the top, there's still an x minus 2 hanging around. And on the bottom, there's a single x plus 4 left. We lost one of the x plus 4s, but we kept one. The key will not have these in parentheses because they're the last of their kind on top and bottom. I'm going to keep them in parentheses to make sure I don't start canceling x's. I cannot cancel those x's because they're parts of polynomials. You cannot cancel parts. You have to cancel the whole thing. It's the same reason you cannot reduce the 2 over 4 to 1/2. That's not a negative 2. That's an x minus 2. And that's not a 4 on the bottom. It's an x plus 4. It's a whole thing. You can't reduce or cancel part of it. You have to do all of it or none of it. All right, we are now going to look at more complicated rationals, still doing multiplying. We'll switch that up in just a little bit, but first of all, let's keep this simple. Let's make our groups. Groups everywhere, so watch for plus and minus signs, and as many things as they're connecting, those are groups, big groups, little groups. So this group on the bottom here is a trinomial. The binomials on top. Second fraction up in the numerator, we have another trinomial. And then in the bottom, we've got our little binomial. So none of them have protecting parentheses that are visible, but they're there. So we're going to fill them in. Now we have things we can cancel already. Excellent. Let's get rid of these. Take out all our rage. Cancel away. Make the math disappear. Now, these last two polynomials are not matches. They do not cancel. However, they can be factored. The square is a good indication that let's break this thing apart. So we're going to look at the back. What can multiply to 30? That's how we start factoring. So we've got all these different factors of 30. So we have 4 different sets of factors that we can choose from. Okay, and there's nothing in front of the x squared. That means we didn't have to get involved. We don't have to do slide divide. We can just work straight from the back factors. So which of these factors times to 30 and subtract to 7? Well, they all times to 30, but who subtracts to 7? That looks like the 10 and the 3 are going to be the things that subtract to 7. So let's go ahead and we're going to break this up. Into the front go the 2 things that times to the front, x and x. And then we're going to put our 3 and our 10 into the back because they subtract to 7. Now here's the catch. They times to 30, but one of them needs to be negative so they can times to a negative 30. That's also what creates the subtraction. So do we want 3 minus 10? Or do we want 10 and a minus 3? Which one of them goes negative? Well, since the 7 is negative, 3 minus 10 is probably what we're after. So that would make 3 positive and the 10 negative. So times to the negative 30, and then 3 minus 10 is the negative 7. Okay, we're going to do the same thing on the other polynomial, the other trinomial. We're going to break up the back term, 15, into its factors. 1 and 15, 3 and 5, and that's about it. 15 doesn't have a lot of factors. which of these will add to 8? Because our link here is addition. What adds to an 8? Well, probably the 3 and the 5. I don't think the 1 and the 15 add to 8. That seems unlikely. So we're going to create the x and the x. And then we're going to insert our 3 and 5 since they're adding to a positive 8 and everybody's positive. We have 2 positive things adding to a positive 8. They also times to a positive 15 and everybody's happy. And we will also have some matches coming out of this. The x plus 3s are going to cancel. They're gone. I like to make these things smaller, neater. So we still have an x minus 10 on top. And no match for him, so he sticks around. There's an x plus 5 on the bottom. And there we go. That's what a more complicated polynomial looks like. You took a big thing, made it into a small thing by factoring. The rest of it doesn't cancel because if it did, you would be canceling parts. Don't cancel the parts. You have to cancel all of the group or none of the group. All right, so over here, the last one for this section, we're going to be doing the same thing. So first of all, scan for polynomials because you don't want to accidentally cancel part of one. So this on the bottom, that's a polynomial. You don't want to accidentally cross off the 9 in that polynomial because you would have just canceled a part. And a polynomial is a big family. They don't split off parts of themselves. So that 9 doesn't cancel the 9 on the polynomial. But the 3's definitely cancel. They are not part of polynomials. Okay, they're not part of bigger groups. The x's also cancel. They're not part of bigger groups. So we've still got a 9 on top, but this group here, there's no x squared, but if you do look at it, maybe there's a common factor, a greatest common factor we could pull out of that. Maybe we could pull a 9 out of that group and reduce the group, kind of undistribute it. 9 times x would be 9x. 9 times the negative 2 would be a negative 18. So that works. And now that 9 is outside of the group, now he's fair game. Now you can cancel because he's no longer part of the group. He left the group. And the group is sad and reduced, but that's their lot. That's just how that group works. All right, so let's look for any leftovers. There is nothing left on top. You know how everything is dividing and canceling? When you divide to canceling, you divide to a 1, so there's still a 1. On the bottom, the only thing that's left is the reduced group x minus 2. And that's it. So much, much smaller fraction, a lot easier to work with. Well done. Now we come to it, dividing rationals. Ooh. Dividing rationals. So let's talk about how you divide with fractions. Rationals being another word for these fractions. So how do you normally divide with fractions? Well, let's go even simpler. Let's talk about how you normally divide. Let's do something really simple. Let's do 8 divided by 2. Most of you will know that that is the number 4. Congratulations. But let's find another way of using 8 and a 2 to get 4. Instead of dividing, let's times that by 1/2. We're basically cutting it in half. 8 cut in half is, it's also 4. Well, that's cool. We use the same starting number. And then we used 8 times 1, 1 times 2. You can reduce them from the side. But yeah, no matter what, that's still 4. The big difference here is the second number and the sign. So, hey, look at that. It's like the 2 flipped over into, if you're one of Mr. E's former students, a multiplicative inverse. It's also known as a reciprocal. So when you change from divide to times, if you want to keep the same equation going, you can flip the second number. And that's the same thing. And that's actually how we divide, is we've been turning them into multiplying problems and flipping the second number. So let's do it with fractions. So you see what it looks like with fractions. All right, so we have 6 over 5, and we're going to divide it by 1 over 5. We're going to copy how division works in the real world, where division, if you flip the second number and times it, it should be the same thing. The reason we want to do this is because division's kind of weird, but we know what multiplication is. So if we can turn this into a multiplication problem, we just did a whole set of notes on how to multiply. We know how to multiply. You keep the front number the same. 6 over 5 has not changed. But we're going to change the divide sign to just a multiplier. Okay? And when we change the sign, we change the number that follows it. We're going to flip it upside down. That's the reciprocal, or the multiplicative inverse, which rolls trippingly off the tongue. Now, we've done this. Hey, look, there's things that are canceling. And we are left with a 6 on top, a 1 on the bottom, and 6 over 1 is also called 6. All right, so that's how division of fractions works. Okay, you change them to multiplication, which is a lot easier to understand. So when you see the division symbol, now if you have a multiplying symbol, you don't do anything. But if you've got a dividing symbol, the dividing symbol, what we're going to do is rewrite this. The first is the same, 6 over 5. Change that operation symbol and flip the second fraction, the one that comes after the operation symbol. Now it's flipped. Now with it flipped, we can go back to what we were doing a little while ago, which is looking for things that cancel. Don't cancel when they're dividing. Okay? Division is weird. Don't cancel when they're dividing. Cancel when it's back to multiplying. So the 6 and the 3 can reduce each by 3. We get a 2, and technically we get a 1 on the bottom. Let's look for other things that can cancel or reduce. I'm not seeing them in the numbers, but with the variables, there are 3 x's on the bottom, and there's 2 on the top. 2 of those x's will take out 2 of those bottom x's, which leaves just 1 of them behind. Okay, so wherever the most x's are, look for the exponents to find the most. That's where the final variables will be. Okay, so let's finish this out. We have 2 times 4 on the top. That's an 8. And then on the bottom, we have 5 and x with no exponent because there's just one of him left. You can put the 5 in if you want to track the exponent, but why? All right, let's try it again. Okay, I see a division symbol. I don't want to divide. Fractions are weird enough. So if you see a division symbol, change it to a multiplier. If you already have a multiplication symbol, you can start canceling. Now, with division, you actually can start canceling as long as it's inside the same fraction. But to avoid confusing things, I'm just going to copy down that first fraction as it is. Now we're going to change this to a multiplier. And when that changes to a multiplier, the second fraction flips. You only flip the second fraction if you're changing out of division into multiplication. Or if you're going backwards, but I wouldn't. Yeah, don't go backwards. Okay, so we're just flipping it upside down. It's a reciprocal or a multiplicative inverse. Okay, we're now ready to look for things that cancel. We've got some x plus 4s that cancel out. And now, because we flipped it into multiplying, we have some x minus 5s that also cancel out. Well, that doesn't leave us much. So the only thing left on top happens to be the number 2. The only thing on the bottom is that number 1. And 2 divided by 1 is just 2, which is a much, much simpler number coming from a fairly complicated beginning. I like this simple stuff. So either one is technically correct. 2 is probably the better answer, but 2 over 1 has its uses. Again, look at the front, look at the end, much simpler. On to the very, very last set. We are ready. Here we go. This will be awesome. Okay, we're looking at more complicated polynomials, and look out, we've got plus signs. So let's get these guys in their groups before we accidentally cancel things we shouldn't cancel. Because remember, you cannot cancel parts of polynomials. And parentheses are a good way of saying, hey, I'm a polynomial. Don't touch parts unless you're going to touch all. Okay, so you don't want like weird parts and pieces breaking off in your hand. No good. Okay, and there's a division symbol. So we're going to turn this back into a form that's a little bit more familiar. We're going to turn this back into multiplication. So the first fraction is unchanged. The first fraction just sits there. So we still have an x plus 2 over 10. Divide symbol, we change that into multiplication, and we flip over the second fraction, not the first fraction. And remember, you only flip when you're changing it out of division. If it's already multiplication, don't flip it, just start canceling. Division is the only one that requires this flip. Okay? All right, so we've got it copied down with the second fraction has now been flipped. Okay, there's a loner 10, but there's no other loner numbers. Yeah, there's another 10, but he's a part of a polynomial. We don't cancel parts. But maybe we can pull out a greatest common factor, or maybe we can split a trinomial into things that can factor. So that's still available to us. So this is coming from the top. We can pull out a common 10, and that leaves behind an x plus 7. We're dividing it out. It's the opposite of distributing, and you should be able to redistribute and get back to where you came from. Okay, this bottom, see that squared? That's a good indication that you might be able to split this. We're going to split this into 2 parentheses. X squared will split into x times x. So the front times us to the front, the back times us to the back. So we need things that times to 42. So what can times to 42? Well, 1 and 42, 2 and 21, let's see, 3 and 14, 5, nope, 4, nope, but 6 and 7 are a go. So they all times to 42, but which of them can also add to 13? Well, not seeing a lot of good candidates except for the last one. 6 and 7 add to 13. Everybody here is positive. That means everybody in the end result will also be positive. So plus 6, plus 7. That doesn't have to be in any particular order, especially since we're about to lose some of it. Okay, and I'm just going to recopy that front fraction down. Nothing's coming out of x plus 2. They don't have anything in common except for maybe a hidden 1. And if it's not negative, pulling it out doesn't serve a lot of purposes. Okay, the 10 is no longer part of the polynomial. It's been removed. It's not a part anymore. That means it's loner 10, which can cancel another loner 10. Looking over other parts of the polynomials and the rationals, we've got x plus 7s. And they can cancel because we're canceling the whole thing. Don't cancel parts of it. Cancel all of the group or none of the group. Okay, and this leaves behind not a lot. Okay, we've got an ink problem. We've got x plus 2 on top. That's the only thing left on top. And the only thing on the bottom is x plus 6. And again, I like to keep them in their groups to make sure I don't accidentally start trying to cancel the x's or reduce the 2 over 6, because those are parts of the polynomial. You can't deal with them in parts. You have to deal with all of it or none of it. So big problem became much smaller problem. That brings us to the very last one. We are now ready for this. Okay, the symbol in the middle is division. We've also got polynomials. There's plus and minus signs. So before you even think about, ooh, maybe I can cancel 4's and x's, don't. They are joined by plus and subtraction signs, which means they're in hidden parentheses. And for a lot of people, it helps to make those parentheses visible so that you don't accidentally start canceling parts. You cannot cancel parts. Okay, that division symbol means we can't start canceling anyway because it's not multiplying. Okay, you cancel when it's multiplying. So we're going to change that into a multiplication. The first fraction, we can just bring that down, but while we're bringing it down, let's go ahead and factor it, just make it a little bit more efficient if we're doing that at the same time. X plus 4 is kind of stuck. So the bottom, the denominator, x plus 4 is just kind of stuck, but the numerator, we could factor that. So what can multiply to get a 45? Well, there's 1 and 45. 2, no, but 3 and 15, that would work. And then 5 and 9, or 9 and 5. And which of these, they all times to 45, but which one of them will subtract to 4? Definitely the 9 and the 5. Nobody else subtracts to a 4. All right, so we're going to go ahead and factor this while we're bringing things down. X squared still splits into x times x. And then the 9 and the 5, or the 5 and the 9, we have to figure out, somebody needs to get a negative because we times to a negative 45, and that's also what causes the subtraction. So is it 9 minus 5, or is it 5 minus 9? Well, the 4 is positive, so it's more likely to be 9 minus 5. So 5 gets the minus, 9 gets the positive. Okay, so we've now factored that out. We're now turning the division into multiplication because that will enable us to cancel, and we're going to flip the second fraction. X plus 4 is now on the top. I see things that are going to cancel already. The new denominator, or the old numerator, he'll go down there, but he has a common factor. 8 can go into both 8 and 40. So let's drag the 8 out of that and see what happens. So remember, you're dividing it out. So in the front, there's the x minus, and then 8 times blank is the 40. The blank is 5. You divided the 40 by the 8, and you got the 5. All right, now with the multiplication, we are ready to cancel. So there's some x minus 5. So remember, you can only cancel top to bottom. You can't cancel top, top, or bottom, bottom. It's different levels cancel. The x plus 4s also cancel. I don't see anything else that could possibly cancel. So it looks like we're done. There's an 8 on the bottom. No other common lone numbers. X plus 9 on the top. There's no other polynomials. And you wouldn't be able to cancel part of it anyway. So on the top, the only thing left over is an x plus 9. On the bottom, there will be an 8. And that is the answer. We have concluded the last division problem.